Welcome, everybody, to the Inner Carnivore Podcast, episode 1 of season 2. I think you guys are going to love the absolutely incredible lineup we have for season 2. Starting off, one of my favorite people in the entire scientific community. He has degrees in exercise physiology, exercise science, a PhD in bioenergetics. He is the author of Why We Get Sick and How Not to Get Sick. He is a professor of cell biology at Brigham Young University, runs a lab devoted to metabolism and specifically insulin. For anybody who is not familiar with his work, I highly recommend checking him out. I think you guys are going to love this chat with Dr. Ben Bikman. Enjoy the listening. As always, remember, please like the show, share the show, leave a review. It helps more than you guys know. Thanks for tuning in, guys. Welcome, everybody, to the show. My guest here, Dr. Ben Bikman. How are you doing, sir?
Hey, Jason, I'm doing great. Thank you so much.
Yeah, no, I'm super excited to get you on here. I'm just going to jump right in. I love going through people's educational backgrounds, not because, and we talked a little bit of this, before we started, not because I necessarily think it lends somebody an expertise over anybody else, but because it's always interesting to me how people arrived at their ideas, right? And how they navigated through to get to the philosophy they currently have. So I know you got your bachelor's in exercise science, which I think is awesome because that's essentially what my bachelor's is in, athletic training. So we took a bunch of the same classes. And then you went on and did more exercise physiology as a master's. And then you got your PhD in bioenergetics. I actually didn't know what that was. The first time that I came across you, I looked you up and I was like, bioenergetics. I was like, what is that? Like, what is bioenergetics and how did you go from exercise physiology into that specific niche?
Yeah. Thanks for the opportunity to describe it, because it was a bit of a fun journey for me. And in hindsight, I am so grateful, almost overwhelmed with gratitude for the little decisions that kind of nudged me on the pathway that I'm on. I mean, to be frank, I kind of felt a little guided, to be honest. And I have no problem admitting that because I'm a very religious guy. But yeah, with exercise science, it really was me pursuing a passion. I'd always been athletically inclined, very involved in sports, always very interested in being healthy. And then it was a sort of moment for me learning as an undergraduate that I had a professor who was an active publishing NIH-funded professor. And he was studying a particular enzyme that now everyone's heard of called AMPK. In fact, he was one of the pioneers in this area. His name was Will Winder. And when he was teaching the class, I was dumbfounded. I'm embarrassed to admit it now, that people were still even doing research into the human body. I honestly thought at the time, we know everything, we're done. I wasn't even aware that there was still biomedical research happening in the realm of human physiology. That was such a revelation to me. It planted a seed in my mind, and I thought that might be a career I want to pursue. And I very much felt sort of pushed into this, or pulled, but I knew that having come to this appreciation of the body from the background of exercise science and exercise physiology, I had a very good appreciation of the body as a whole. But looking at the professors that I'd had, I knew that if I stayed at this kind of whole body level, I'm going to have such fundamental gaps in my knowledge that I would probably never overcome them. That if I wanted to become a basic scientist, I needed to get more basic and get back into the cell. And when I started looking at programs, I didn't feel like I had enough background to get a PhD in biochemistry, even though that was what I was getting more interested in as I was really wanting to understand metabolism more. There were two programs at the time, and there still may only be two, that had a PhD in bioenergetics. One was at Ball State University, and then the other one was at East Carolina University. And there was one particular scientist at ECU named Linus Dohm, Dohm. Anyone could look up his work. His CV is enormous, and he was just heaven sent. He was such a wonderful man and mentor to me, and he knew what mattered most, which is certainly faith and family, but also that the purpose of a PhD is to help the individual get as much training as they can to qualify them as quickly as possible to move on to that next step, which in my case would have been a postdoctoral fellowship, which I did with Duke in diabetes research, and then just get hired as a professor. Too often, an academic will look at a PhD student and think, I'm going to keep this kid here for 6 or 7 years and it's slave labor. Linus did not feel that way. He was totally devoted to me and my career. And I was able to get in and out very quickly and be very productive. But it also helped galvanize my interest in insulin resistance. And at the time, how fat metabolism complicates insulin resistance. And that, Linus put me on the path that I'm still on. And I'm truly just so grateful to him. And my postdoctoral mentor was a very similar kind of character, Scott Summers. Once again, looking at me and wanting to develop me rather than just using me as a tool to kind of attain his own ends. That I was an end unto myself, that I wasn't just a means to his ends. And they both were so influential in my life. Anyway, I'm waxing a little personal, but I would want students, future possible students to hear this, to know that you need to be mindful of the environment you put yourselves in and look at that potential mentor. Are they going to mentor you or are they just going to use you? I am so grateful that I had mentors who had my best interests in mind, so much so partly from my affection for them and what they were able to teach me and what I was able to learn, that it has really put me on this path to just appreciating metabolism. And bioenergetics, then to sum it all up, is kind of this, bioenergetics is sort of this hybrid degree of nutrient biochemistry, but put in the context of physiology with obesity and diabetes research.
Okay. So I really appreciate that you said that about being shocked that they kept doing research, because I don't have a PhD. My master's is actually in something other than science, but getting out of my undergrad, which a lot of athletic trainers get their masters, but getting out of that program, I am eligible to sit for the athletic training commission. I thought the exact same thing, like not so much from a research standpoint, but I never once went through school and questioned whether we knew everything. Like professors, I had some great professors, but professors that told you what it was, this is how it works, and this is what you do, especially when it came to nutrition, right? And I get super deep into nutrition, but I took the nutrition classes, the exercise phys classes, the drug education classes, how that affects your body and all that. And never once did I come out with this thought that there might be multiple pathways. And so I appreciate that you said that, because so many people that even I talk to are like, no, this is scientific fact. If I could erase one thing from anybody ever saying, it's this scientific fact. And I'm like,
no, Jason, I totally agree, especially within the realm of biology, which we start to talk about when it comes to nutrition. You're getting into the realm of the living thing. So you're getting into the realm of biology. This is not physics. You can't talk about these absolute laws like you can in the physical, in the physics. Within that realm of mathematics and physics, you can start to talk about absolutes and gravity. All right, yep, this is a fact. But when it comes to biology, I consider what we have seen happening within the realm of nutrition research. It's been happening for decades. These statements of fact, where it is far more dogma-based than data-based, but especially within the last 5 years or so, for reasons that I won't get into, it's kind of been the death of true science, where my PhD mentor, Linus, I remember I will never forget. It was such a seminal moment for me. I had come to him just having performed what's called a Western blot. I'd been looking at levels of different protein, the expression of proteins in a particular sample. And I was so disheartened because the data absolutely rejected or refuted my hypothesis at the time. And I thought, oh my gosh, what a bummer, what a waste of time. And Linus said, Ben, this is not a waste. What is a scientist? And he taught me that a scientist is a seeker of truth. That's what he said. And then he went on to say in various words that we can never become so married to a hypothesis that we start to ignore the data that we deem inconvenient because it doesn't fit our hypothesis or our view or the conclusion that we want. That's what we have seen happening. Again, it's certainly been happening within the realm of nutrition research. One of the reasons I beat the drum of low carbohydrate or ketogenic or even carnivore diets so loudly isn't because I want to be seen as an advocate of these approaches. I don't necessarily want to be an advocate. Now, people may hear me say this and roll their eyes. What I want to be is a defender, because so many people have such mistaken views of carbohydrate restriction in general that they think what they've heard, blue zones, plant-based, vegetarian, all of this nonsense, Mediterranean diets, those terms don't even mean anything. They're really more nowadays articles of faith than they are declarations of data, that it is dogma over data in many of these people's minds. And it's so much so that they don't even know it, that many of them make these claims, and it's not even born from malice, but rather total ignorance. I think in some instances it is malice. But to be frank, I think there are vested interests that benefit when we are less healthy. I won't get into that, but suffice it to say, what you just articulated, I articulate often to my own students. I encourage them to even challenge what I'm showing you. But one of the reasons I don't rely on a textbook as a professor is I don't want some other PhD telling me what I'm teaching my students. So every class I put together, I only rely on original source peer-reviewed evidence. Even something as basic as physiology, or my other classes, pathophysiology or endocrinology, I go to primary peer-reviewed literature. I do not rely on textbooks. I don't want some other PhD giving me a filter. And a lot of students will come up to me often and say, hey, professor, what you just showed me doesn't jive with what I learned in another class. And I said, isn't it awesome being treated like an adult? It's okay to have these competing ideas. Your challenge now as a student is to wonder, who's telling me the reality? Professor Bikman mentions that a low-carb diet can be therapeutic or curative for type 2 diabetes. My other professor says that it's saturated fat that causes type 2 diabetes. And I'll say, let's look at the evidence. I showed you these clinical studies when I mentioned, did your professor show you clinical studies? No. All right, well, find some. Challenge what I presented to you. But the students are so struck by what I teach them because I'm the only one who teaches it. Every other professor they get, if they're coming from a nutritional sort of bend, and I'm not a nutrition professor, I'm a cell biology professor, but I feel inclined to mention these things from time to time, and it just really leaves an impression because I'm the only voice they hear at an academic level who even mentions the word ketone in a remotely positive light. Every other professor is going to talk about ketones in a totally negative perspective. We're just publishing, Jason, we just had a paper accepted over the weekend documenting how ketones, beta-hydroxybutyrate, are sufficient to totally wipe out the inflammation caused by uric acid, for example. And like one more instance of how ketones are having a direct biological level benefit in an organism, and yet all their other professors will not only never contribute their own research on ketones, they don't study ketones, but they won't even be familiar with the research that's out there, and they don't want to. It's too inconvenient for them, and it challenges what they know, and nothing threatens a PhD more than challenging what they think they know.
That is so true. And I think one of the things, like, so it's unique for me because I don't have like the educational background to act like an authority, right? Which most people want. Like, we try and say that we don't want to appeal to authority. We don't create these logical fallacies. But that most people go, well, what gives you, the right to make these statements? And I think what you hit on the head is this idea that there's so much nuance, right? Like, I can go find research that looks this way, and then I can go find research that looks this way, and then you go, well, how does that work? So how do you separate, or how do you explain to someone that biology is not physics? Because everybody wants it to be, right? Like, if I hear the first law of thermodynamics one more time, I'm going to lose my mind.
I know.
And you don't have to go super into it. Like, I've watched some of your videos, and I'll reference people to, your videos on thermodynamics specifically. But how do we get people to separate physics, I drop something, right? Gravity's going to make it fall to the ground, and biology, which has so much more going on with it.
Mm-hmm. Yeah. Yeah. Well, I think it's important. I think it really is important for people to understand that science is the never-ending process of trying to prove yourself wrong. That is, in its simplest, like even at an elementary school level, when you talk about science, you propose a hypothesis, and then there is the null hypothesis that is born the moment you propose your project, which is that what I've just thought is the case may not be the case. That's the null hypothesis. And then every experiment you do, you're essentially doing it to see whether what you just proposed is incorrect, whether the data supports the hypothesis or the null hypothesis, the opposite of what you're proposing. So that's, I think if people just appreciate the scientific process, you create a hypothesis, you create a set of experiments that are going to try to prove that wrong. And then the longer you cannot prove it wrong, the more confidence you get in that hypothesis. So when something can become an absolute, like the theory of gravity, prove it wrong. I'm trying to prove it wrong. The longer we've been unable to disprove or to falsify the law of, or theory of gravity, the more confidence we have that this is an absolute. But when people start to then move that into biology, we are now dealing with not absolutes. We're dealing with a lot of nuance and a complexity that you don't see very often in something like physics, where biology, even at the level of the cell, the simplest level, is so complicated. There are so many variables that come into it. And to the lay audience, who is just as smart as someone with a PhD. Getting a PhD is not a symbol of intelligence. It is a symbol of some patience, some persistence, some self-flagellation, and humility. You ought to have been humiliated a little bit. That's something a PhD should be good at. You should have been told repeatedly how wrong you are on various occasions, and that is somehow getting worked out of the system. In a polite way, sure, but you should come out with a degree of humility, especially because if you're in the sciences, you know that there could be a data set or a paper or a series of papers that come out that suggest everything you've ever done is incorrect. And so I guess one way of summing all of this up to the audience is maybe back to the example I'd mentioned earlier. Professor Bikman showing students that a low-carbohydrate diet is curative for type 2 diabetes. Students being told by other professors that saturated fat causes diabetes. I ask the students to appreciate the source of such claims, whereas I am showing them double-blind, placebo-controlled clinical studies where you take a group of people, you do one single intervention, and you look at the outcome of that intervention. Boy, that has a lot of power. That gives you a lot of confidence in stating that the one thing I did resulted in this outcome. Whereas the other studies where they're saying saturated fats causing type 2 diabetes, those are going to be overwhelmingly, if not exclusively, conducted at a population level, which gets us into the realm, leaving causality behind, into the realm of correlation. And everyone in your audience probably knows those things, these terms, but a correlational study is a type of study that can only indicate coincidence. Although that's an unsavory way of saying it, and those types of scientists wouldn't want me saying that word, but that's all it is. It's a coincidence, and it is filled with confounding variables. Like I'll never forget a paper published a couple years ago suggesting eggs cause type 2 diabetes. This was a paper published in Japan, and when you actually looked at how they determined what eating an egg meant, it included, and you had to really dig in the study to find this, which an average individual is never going to do. They probably don't have access to the paper because it's behind a paywall, and it's written in a technical enough jargon that the average person doesn't know those terms, not because they're stupid, just because they haven't learned them. And so they don't really follow it even very well. But in that paper, they noted that they considered eating an egg if the person was eating anything baked with an egg, including cakes and cookies and the like. And yet, what's the headline? Of course, they don't vilify the sugar, but you would be just as justified in saying sugar causes diabetes from their own data set as you would have making the claim that eggs are somehow causing diabetes. So with this example, it's just on my mind because I literally had a version of this conversation with students recently. I asked them to look up the dietary right there at the end of class. I said, open up your laptop. What's happened to the saturated fat consumption within the United States for the past 100 years? It has gone down. Then I said, what's happened to type 2 diabetes prevalence in the past 100 years? It has gone up. Even at that same stupid population level perspective, it doesn't work. You have to torture and tease the data so much. But Jason, at the risk of going on a tangent, to me, this is all a further reflection of a general warfare on human health. That one of the ways, which itself has some bizarre background, as I noted, I'm a very religious guy, and I have no problem reconciling my faith with my rigorous pursuit of truth in the realm of science. Some things can be proven in this sort of physical realm where I can do one thing and see the outcome. Some things cannot. And everyone relies on some degree of faith, whether it's in their daily life. They're going to do one thing and hope for this particular outcome. That's a manifestation of faith. Anyone who's trying to lose weight, they're doing so on faith. They're hoping that they're listening to Jason and they're going to say, I've seen Jason say this. I have faith that what Jason's telling me is true, and so I'm going to do it. That's a matter of faith. And so I have faith in science. I have faith in my own religion. However, back to my point, pardon me for the tangent there.
No, I love it.
But people in the US in particular, we have a weird little history of a certain religious group, and I don't want to speak evil of them, so I won't mention it by name, but you have the influence of a particular religion in the United States that heavily regulated the nutritional policy within the United States, even from its very inception of the food guide pyramid. That was created by a particular religious organization. The American Dietetics Association, it was created by that same religious organization, and that religious organization continues to have a huge part in the funding and the sourcing for this American Dietetics Association. So a central tenet of this religion is that meat is bad, that eating meat is evil. And so back to my point, I think a lot of what we see is this steady influence of various characters born from malice or even from ignorant but good intentions, misplaced good intentions. There is a fear of animal-based products. And they say that fear is because of the presence of saturated fats in those animal-based products. And to me, the evidence has never supported it. And so I reject that premise. And indeed go even further by stating that the further a human gets from animal-based foods, the worse their health will be. You've probably seen this economics group out of Australia that actually went through these blue zones in an effort to try to reconcile the impossibility where these same areas of the world, like Okinawa and Sicily, that were reporting this abnormally high number of people living into their hundreds, happened to be in the same exact places where the average lifespan was lower than the rest of the country. And smoking rates were higher, drinking rates were higher, and illiteracy rates were higher than the rest of the country, outside of Okinawa with regards to Japan, and outside of Sicily with regards to those areas of Italy. And what they concluded was that this apparent paradox, this impossibility, how can you have these people somehow living way older than normal, and yet they have all these terrible health outcomes in general, was based on this. They concluded that it's totally a function of fabrication of records. That basically you had people who did not have documentation of their original birth and thus were lying about their age, and in some instances deliberately lying, or in some instances family members lying that the individual was still alive so that they could reap the government assistance that was coming to these people. So it was people lying about their age to start getting pension earlier, or family members lying about the person still being alive. There are actual documented evidences of all of this. So the whole phenomenon of blue zones appears to be, once again, a total fabrication. And people within the US will often cite the Seventh-day Adventists in Loma Linda and say, well, this is a U.S. blue zone because look at these Seventh-day Adventists who don't eat meat. Well, there is another religious organization who has some similarities with the Seventh-day Adventists, namely the Church of Jesus Christ of Latter-day Saints, or the Mormons. Being at Brigham Young University, that's the church that sponsors my university. And what they have in similar is that both religions encourage the avoidance of tobacco, so no smoking, the avoidance of alcohol, so there's no drinking, and strong social networks. But whereas the Seventh-day Adventists don't eat meat, members of the LDS faith eat plenty of meat, and they live just as long as the Seventh-day Adventists do. And so even within the US, we have this confounding variable, what's referred to as the healthy user bias, where the same people who tend to avoid eating meat as an act of improving their health often engage in other behaviors that are difficult to quantify. They tend to exercise a little more, they tend to drink a little less, smoke a little less, and just sleep a little better, and in generally engage in better overall kind of societal and personal behavior. That's why they live longer. It's not because they're avoiding meat. In fact, I'm speaking so much of religion, which I had no intention to do, Jason. So please pardon me in the audience. I didn't mean to take it this way, but I actually think you have to appreciate the role of religion to understand the war on animal-based products, because that is its origin. It was never based in science. It was science with some religion influencing the interpretation of the results. And that created a beast that has just continued to demand the data follow a particular story. But even those who invoke religion, I encourage anyone to open up their New Testament and read in 1 Timothy chapter 4. In fact, I shared this with you on an X post. You'd mentioned some scriptures defending the eating of meat in a religious context, and I thought you'd left out the best one, which is the Apostle Paul absolutely bringing down the hammer on people who command to abstain from meat. That's what he said. He basically said that people who command to abstain from eating meat have been seduced by the devil, basically. So that's 1 Timothy chapter 4. Anyway, I don't want someone to think I'm some crazy religious zealot. I'm very religious, but I approach these things absolutely like a scientist.
No, that's totally fine. I don't like shout from my platforms, but no, I am of a similar faith and a similar ideology. But it's interesting you brought up the blue zones. Another one that's in there is Kenya has the 4th highest rate of centenarians in the world, right? They also simultaneously have like the 236th lowest life expectancy. And you're like, so you either live really long or you die really early, which doesn't make sense.
No, it doesn't. Yeah, that's the thing. Like with a little bit of scratching beneath the surface, you start to see that this is just a house of cards. It's just, there's no foundation to any of this.
And the two you brought up about studies, the egg one is super interesting because I first discovered that when I first pulled up my first FFQ. And for most people who follow me know what a food frequency questionnaire is. But when I saw, especially from like the nurses project, I'm butchering the name, which they use a lot in these epidemiological studies. And you go through and look at what classifies as red meat. And they'll be like mixed dishes, pasta dishes, burgers, like anything of that. Like you said, they bake with an egg, that counts as an egg.
Mm-hmm.
And you start looking at that. And then also into your lifestyle thing, I found that in a fiber paper where they're like fiber reduces, all-cause mortality. And oftentimes, if you just read the study, and it is difficult to find studies sometimes, like there's behind paywalls and all this, but oftentimes when you find a study, an author will actually allude to this. And in this paper, they're like, now the people that ate more fiber oftentimes smoked less, drank less, exercised more, and, general cared about their health more. And so that brings it all back into it. And it just blows my mind that, like you said, these headlines, you'll see whether it's CNN or, the Daily Mail, whatever it is, red meat causes this or red meat causes that. And then you have to go into all of these studies, and it blows my mind how we've gotten from, this paper with all these confounding factors to this headline. And oftentimes the conclusion that the authors come to even matches that headline, which is even more confusing to me.
Yeah. In fact, what is so funny is my seeing this at the level of my own lab and my own data. So over the past handful of years, we've published dozens of peer-reviewed science manuscripts. We'd published a series of about 2 or 3 manuscripts that I considered to be absolutely phenomenal. By way of brief background, I have long maintained that the lower insulin gets, the less relevant calories are. So you and I mentioning thermodynamics earlier, yeah, energy matters. Neither Jason nor I are stating energy doesn't matter, but we are not a perfect thermodynamic machine. And so trying to invoke the laws of thermodynamics are silly. In fact, I think giving food a caloric value, a value of a physics unit of measuring heat, was one of the dumbest things that ever could have been invoked within the realm of nutrition research. But that's where we are. But it's born from this idea of building a machine, building the perfect steam engine, actually. That's the origins of the laws of thermodynamics. We are not steam engines. We are much more complicated, unfortunately. But the lower insulin gets, the more impossible it becomes for the body to store energy. One of the ways it reconciles this is through the production of ketones. Ketones are a bit of an energetic release valve, a pressure valve, where if the body is continuing to consume calories, but insulin is down, then the production of ketones is a way to reconcile the inability of the body to store energy because insulin's low. Not only because the excretion of the ketones themselves are calories leaving the body or a caloric equivalent, because every single ketone that's coming out has a calorie load roughly equivalent to glucose. And now if a person's in ketosis, they're just breathing out calories. They're urinating out calories. But my lab's work found that ketones also resulted in this process of reduced mitochondrial efficiency, which sounds like a bad thing, but if you're trying to lose weight, it's a great thing. Basically, the mitochondria it's like an engine where you're riding the clutch and you're revving the RPMs, but you're not actually moving. That's a great way to burn a lot of fuel without getting a lot of work done. If you've got a lot of fat tissue on you, that's perfect. You want to be burning a lot of energy. And we found in humans, we actually took fat biopsies from humans in ketosis and not in ketosis, and rodents, and at the level of the fat cell itself. I mean, it was an awesome study. It's probably the study I'm most proud of from my lab in the last 10 years. No one cared at all. Not a single media outlet published a single paper on this finding that ketones increased the metabolic rate of fat tissue in humans by 3 times. So it was like when we pulled out a fat biopsy of a human in ketosis, their metabolic rate in their fat tissue was 3 times higher than the fat tissue metabolic rate of someone who was not in ketosis. No one cared. Not a single cricket chirping in response to us sort of floating this out to media outlets. And then just 6 months ago or so, my lab published a paper finding that diesel exhaust has the ability to promote fat cell growth. That was multiple media outlets picking that up, of course, because it fits this idea of environmentalism, which I don't want to that gets us into a deeper area where, people want to promote alternative fuels and they want to vilify these carbon-based fuels. And this sort of fit into that narrative, that another reason to drive electric cars or whatever. And I was so disheartened. Yes, I'm proud of that study. It's a very cool study, finding that once again, there are these non-caloric influences that in these animals that were breathing in diesel exhaust particles at a human level, their fat cells were bigger. They were eating the exact same amount of food as the other animals, and yet their fat cells were larger. That is cool, but I don't think it was nearly as cool as the papers we found, including from humans, that in ketosis, metabolic rate in fat tissue tripled. No one touched it because they don't want to talk about ketones. Ketones are bad. Maybe people will follow a ketogenic diet. We can't have that. So there is a bias, and it is so deeply entrenched within science and media that if you try to float this idea that animal-based foods are healthy, I would add essential. They are literally essential to human thriving. They don't want to hear it. But in fact, Jason, if you'll allow me to, I think that's another layer to this, that a lot of this may be cynical, but a lot of the kind of anti-energy perspective and anti-animal based food perspective, I think at its core is this view that there are too many humans on the earth and we need to reduce the population. I know that may be cynical, but I think that these are both interventions, sort of forcing vegetarian diets and forcing this alternative energy source, these alternative, very unreliable energy sources on humans. Those are two ways to make humans unable to thrive. If you deprive them of energy, there are stories of forcing clinics that get international funding in Africa to only rely on solar energy, and them being unable to operate ultrasound machines and having women and their babies dying because they can't do the ultrasound because they don't have sufficient energy in the night. So it is directly harming human thriving. But then when it comes to nutrition, we know in men and women that, especially in men, if you start to restrict saturated fat from their diet, their testosterone production goes down and their sperm quality goes down. I mean, you are literally preventing people from reproducing. And so I know it's cynical to say, but I can't help but think that a lot of these interventions, what they may have in common is this kind of anti-human view that humans are a plague on the planet, and that the less of us there is, the more pristine the planet can be, which is in direct contrast to my view, which is that the planet is for us, that we are master and commander of this planet. Yes, we should be good stewards of it, but it literally exists for us to multiply and replenish the earth. So my advice to everyone, have babies and have as many as you can.
No, so had you told me that probably even a year ago, I would have been like, all right, that's a little cynical. Like that's a little conspiracy theory. But then I look at where we're at from just a medicine and a technology and what we have an understanding. And then I look at, you alluded to diabetes, and we look at all of these factors that keep getting worse, like the rate of diabetes, the rate of obesity, the rate of overweight. Everybody likes to harp on the death rate from heart disease. It's actually super difficult to find the actual incident rate of heart disease. It is very difficult to find that on Google. I had to go, I couldn't even get it from Chat GPT. But the actual rate of heart disease is following the increase in population. So we're continuing to we're not lessening heart disease. We're just not dying from our first heart attack anymore. And
well said.
All of these factors are indicating that we're worse health-wise. And then you look at life expectancy, we're second in the world in life expectancy, or 60th actually, which is atrocious for considering, socioeconomic status and life expectancy go almost hand in hand, except for 3 countries in the world: South Africa, Russia, and the United States, which doesn't make I can tell you why South Africa and Russia, but the United States doesn't make sense. So you saying that now, and then you just look at the testosterone rates. I think one of them is, the average 20-year-old has the testosterone of a 70-year-old from 30 years ago. And you're like, so testosterone's going down, sperm's going down, sperm quality's going down. You start looking at it and you're like, that's not so much cynical. That's literally just stating factual information that literally anybody can look up.
Yeah, that's right. Yeah, it's as crazy as it sounds at first glance. And some people could kind of wrap that into their own summary. But regardless, the evidence stands that whatever we're doing currently, whatever the motivation, whether it's kind of an anti-human view, like I alluded to, or a pursuit of greater wealth. And I'm a capitalist to my very soul. I've been to enough communist countries, lived in some in the past, that I have a particular hatred for that form of economy and government. But regardless, whether it's a pursuit of wealth, whether it is a pursuit of power, whether it is the pursuit of an ideology wherein, as I've now mentioned multiple times, humans are a unique problem on the planet and there ought to be fewer of us, I reject all of those. That I just want truth. In this realm, I want truth as much as we can identify it, and just honesty. And that's what I try to bring to my classes that I teach. I try to kind of balance that, walk that line with my own students, where I want them to respect me enough to listen, to maintain a kind of proper order in the classroom. I don't want chaos. There needs to be a hierarchy. But at the same time, I want them to know that I don't consider the data I'm presenting to be infallible, but that in the absence of being able to prove these data sets wrong that I'm showing them, no matter what else they might have learned, either I'm wrong or their other professor may be wrong, and they now are being treated like adults, and they need to reconcile that. And I will tell them, I'll say, look, you're welcome that I'm treating, like they'll say, Bikman, I can't reconcile this. You just said this, they just said that. Now, this all makes it sound like all I talk about is nutrition. That's actually a small part of my class. It just has an outsized influence. When I talk about diabetes in my endocrinology class, type 2, you bet I talk about low carb and ketogenic diets. That just blows their minds so thoroughly that they want to explore it more and they want to talk about it more. And then they try to reconcile what I've shown them, including my own data, with what they've heard in other classes, that a keto diet is going to kill you and it's a stress and it's going to burn your brain out, or whatever the nonsense is that they hear. I swear it's just professors who just make stuff up. And they think they can get away with it because they got a PhD. I mean, boy, you want to find ego, just hang out around a university. Now, I love being a professor, but I am so mindful of the ego that is too inclined to come. And why am I different? I don't know. It's probably because I have 7 older brothers, and nothing humbles you more than being the youngest of the 8 boys in the family.
And like social media just brings that even more out. Like I've done videos of PhDs, and they don't go into nuance, but they just make statements like keto doesn't work. And I'm like, you can't. Like, you can disagree with it, fine. You can cite studies that you don't think it's beneficial, but you cannot have your level of education and not understand that it works, even for a small group of people. So making a statement like that is one of the most absurd things that I see from people with PhDs is they make these blanket statements. This does not work, or this will kill you. And it drives me insane. So the last thing I want to touch on, before we wrap it up, is I would like your opinion on our current energy balance model of obesity. And if you have tweaks to that, what do you think is causing our current, because we're almost 50% obesity, right? Like it's a problem. What is causing, or what is contributing to that in our current society?
Yeah. I remember reading an article by Gerald Reaven, and he had published a paper entitled something like Physiology of Insulin in Man. And at the end of it, it was very interesting because it showed he'd given this as a presentation at some medical association meeting. And there was a Q&A at the end of the publication. And one of the questions from this physician group was, what would you say is the simplest but most obvious difference between lean and obese individuals? And he had one word answer: insulin. That is the one irreconcilable thing, that as much as we have a culture that is utterly, totally obsessed on calories, I can prove that wrong right now. Take a type 1 diabetic, and if that type 1 diabetic stops injecting insulin, they cannot, not only will they not gain any weight, even if they're eating 10,000 calories a day, but in the midst of eating those 10,000 calories a day, they will be getting scrawnier and scrawnier, burning through all of their fat tissue, and then eventually burning through muscle and fat. That's the difference between a fast and a starvation, just as a point of interest. Do you have any more fat to burn? Once you run out of fat, now the fast is over. Even if it's 382 days, like it was in the case of a Scottish man, documented in a clinical published case report. Once you lose your fat, now you've gone into the realm of starvation, where you're burning your muscle and bone, etc., for energy, rather than fat now, having run out of it. So you can take the type 1 diabetic, skip an insulin injection. They'll be as skinny as they want it. So to answer the the second part of your question, why are we so obese? There has to be 2 variables that must be both elevated to promote obesity. You cannot have obesity without both of them. The conventional view is that it's only calories. Energy matters, but only if the fat cell knows what to do with that energy. How does the fat cell know what to do with energy? Insulin tells it what to do. So, in order to promote fat growth, you must have elevated insulin, because that stimulates the growth of the fat cell. There is no other signal. People want to invoke stress hormones. They want to invoke ACP. They want to invoke anything else. Lack of thyroid. No. Those all matter. They all are part of the little cocktail of influence. But I can remove those pieces and still grow the fat cell if insulin is elevated. So insulin stands alone with utter supremacy over the growing and shrinking of the fat cell. If insulin is up, it is an undeniable signal to the fat cell it's time to grow. That's not enough, though, because it's one thing to tell the fat cell to grow with elevated insulin, but it's another thing to give it the building blocks that it needs to grow. And that's where energy comes into play. There must be the carbons. I'm calling it energy, and yet I was just criticizing the calorie earlier. It's not energy. And you have a brilliant video criticizing the silly and flagrant use of the word energy, because it's not like you can run a line of electricity into the human body and make someone become obese. So it's the carbons that we call calories and energy, because if we burn them, they will give a flame. They will give heat if we heat them up, but it's carbons. So that is what I'm calling energy. It's not energy. It's the physical building blocks. Whether those carbons are coming from glucose or whether they're coming from fat, that will provide the building blocks of creating the fat that will fill the fat cell in response to insulin's demanding that the fat cell get big. So both of those conditions must be met. Just to elaborate on both of those, and then that sort of lends itself into talking about the solution then. If you have one without the other, it's incompatible with life. So just so people really appreciate that, I'm not stating that it's only insulin. I beat that drum so loudly because too few people are. Every other expert outside of mine, your realms, is mostly just talking about the calories. If you have elevated insulin, but low energy, that's incompatible with survival. That if someone stopped eating, insulin would naturally come down. But if they injected themselves with a dose of insulin, they would go unconscious and potentially die because they push all of the energy out of the blood, because that's what insulin wants to do. And now the brain doesn't have enough to work, and so the brain shuts off. So high insulin with low energy, incompatible, unconscious, and then death. In contrast, low insulin, high energy, like the scenario I mentioned earlier, the overeating yet underdosing type 1 diabetic, they will live for a while, but eventually they will burn their body apart with ketoacidosis, and which is not the same as ketosis. Ketoacidosis, almost 10 times higher ketone levels than the average person can get, 5 to 10 times higher, again, than the average person could ever hope to get to. Like the case of the 382-day fasting Scotsman, he never went into ketoacidosis. He only went to ketosis because he was making insulin the whole time for reasons that we won't get into perhaps. But in that case, with low insulin, high energy, you're going to waste away because you can't store any energy even in your bones and your muscles, and you'll waste away and you'll die. So that is also incompatible with survival. So both are required to stimulate fat growth. The reason, again, I beat the drum of insulin so loudly is because if a person is told all calories are equal, then of course you're going to eat the delicious ones. And we just don't pay any mind to the fact that you're going to want to overeat them. There is so much obsession on GLP-1 right now. And I think it's not inappropriate. I think the use of these GLP-1 drugs has gone way too far. But obese people have been shown that when they eat a given load of carbohydrate, their GLP-1 response will be half of the response that you see in a lean individual. And GLP-1 promotes satiety. So it's no wonder that once the obese person's eating these carbs, because that's the one type of food we crave, they want to keep eating it. They're not getting that good enough satiety signal that their lean counterpart may be getting. So, but they'd be told that it's only calories. No, you also ought to consider the insulin load. So, Jason, if I had I've actually been thinking about this over the past week. Wouldn't it be amazing if we could have some formula that could, yes, sure, mention the calories, even though calories are stupid. We ought to have a unit of carbons tracking the amount of carbons you're eating, but I don't think we'd ever get there. Let's still just keep the calorie in as kind of a surrogate indicator of the amount of carbons. Although protein should never be given a calorie amount. You don't use protein for fuel. When you talk about calories, you're talking about what is energizing your body. That's protein, that's fats and carbs. So wouldn't it be amazing if we could have a metric that considered the calorie load coming in addition to the insulin effect? Because now you understand the potential of your body to store what you're eating. If what you're eating would be relatively fewer calories, but a higher insulin effect, you're going to store more fat than something that might have had a higher or an equal amount if something had more energy, But a lower insulin effect, well, then you're going to waste some off the top. You're just burning off the excess. That's that kind of metabolic release valve that I mentioned earlier with ketogenesis and the excretion of ketones and the uncoupling of the mitochondria or the increased energy burning. So it'd be amazing if we could have a way of a food label saying, here's your score, and it's a combination of the insulin response and the energy or the carbons you're getting. Then you would be looking at both variables. But a final point, as much as one of the problems with the conventional weight loss advice is that it is only ever based on calories. If you tell someone who's eating a lot and they have high insulin, because those are the two required aspects to promote the weight gain in the first place, to just simply stop eating, and the energy consumption goes down, but the insulin takes a little time to start coming down. It's no wonder they fail so often, because as I mentioned earlier, if insulin's high but energy is going down, you start clearing all of that energy out of your blood. And before the brain shuts off and goes unconscious, it's going to want to tell you to eat more. It's going to sense this reduction in available energy, even though the fat cell is getting plenty, because insulin's feeding the fat cell first. The brain is going to sense a reduction in energy, and it's going to want to correct it by stimulating hunger. So if their first step of their weight loss journey is, I'm going to cut back on my energy, without addressing the insulin, they're going to get very hungry very quickly, and before they know it, they're right back where they started. So let your first step, both of these variables matter, insulin and energy. Let your first step be, I'm going to lower my insulin. I'm not going to worry about my energy. If I'm hungry, I eat. If I'm not hungry, I don't eat. But I'm going to lower my insulin first by controlling carbohydrates. Don't get your carbs from bags and boxes with barcodes. Whole fruits and vegetables, depending on where you're starting, okay, eat them, don't drink them. Let that be the first step you take. And then you're going to lose a lot of weight. You're going to feel better. And maybe that's enough. Maybe you're done. And maybe it's just really fine-tuning those carbs more, even going to the level of carnivore. I have no problem with that. That is profoundly therapeutic in a number of ways, weight loss and type 2 diabetes reversal, autoimmune reversal included. And I'm thrilled that that's getting more and more attention. I'm thrilled. But let lower insulin first. And then if you find you get to a weight loss plateau and you need to go a little further, then you can look at your energy. And if you do think, okay, I'm eating 2,000 calories a day by drinking butter in my buttered coffee or whatever, all right, now it's time to start looking at the energy. But even then, I actually think the best way to do it is through structured fasting, where you're not really counting your calories. Never count your calories. Just get to a point where you have a fasting structure that works. So lower insulin first, and then if needed, revisit your energy.
I really appreciate you coming on, Ben. For anybody who wants more information, Ben has a ton of educational videos on his YouTube. I have learned a ton from that. I really, really appreciate you coming on. Thanks everybody for tuning in, and we'll see you guys next time.